NVIDIA just unveiled the Vera Rubin, and it is 10 times faster than anything we have today. We are talking about a single chip that can process 50 quadrillion operations per second. If you think AI is powerful now, wait until you see what this thing can do. The Vera Rubin is not just an incremental upgrade. It is a generational leap that will redefine what is possible in artificial intelligence, and it is launching in the second half of 2026. The NVIDIA Vera Rubin is the next generation of AI processors, and it represents the most significant architectural shift in NVIDIA's history. Built on TSMC's cutting-edge 3-nanometer process, each Vera Rubin GPU packs a staggering 336 billion transistors. That is nearly double the transistor count of NVIDIA's previous Blackwell architecture, which had around 208 billion transistors. The chip is named after Vera Rubin, the pioneering astronomer who provided the first observational evidence for dark matter. This naming choice reflects NVIDIA's ambition to explore the unknown frontiers of computing, just as Vera Rubin explored the unknown frontiers of astrophysics. Her work fundamentally changed our understanding of the universe, and NVIDIA hopes this chip will fundamentally change our understanding of what artificial intelligence can do. The Vera Rubin is part of a larger platform called the Vera Rubin platform, which includes the Vera CPU with 88 ARM Olympus cores and 36 of these Rubin GPUs working together in a single liquid-cooled rack. This rack-scale design, known as the NVL72, is the foundation of NVIDIA's next-generation AI supercomputing infrastructure. The entire rack consumes approximately 166 kilowatts of power, all delivered through a revolutionary liquid cooling system that eliminates the need for traditional fans and air conditioning. Let us talk about the raw specifications, because these numbers are truly staggering. Each Vera Rubin GPU comes with 288 gigabytes of HBM4 memory, delivering up to 22 terabytes per second of memory bandwidth. That is nearly 3 times the 8 terabytes per second of the previous generation HBM3E memory found in Blackwell GPUs. This massive memory bandwidth is critical for AI workloads, where models need to access enormous amounts of data every single second during training and inference. In terms of raw compute, each GPU delivers 50 petaflops of inference performance in FP4 precision. To put that in perspective, 50 petaflops means 50 quadrillion floating-point operations per second. At the rack level, a full NVL72 system with 72 GPUs delivers 1.4 exaflops of FP8 throughput. An exaflop is a billion operations per second. The fastest supercomputers in the world just 5 years ago operated at around 100 petaflops. The Vera Rubin rack outperforms them by a factor of 14, and it does so in a single rack that fits in a standard data center room. The GPU also features NVLink 6, which doubles the chip-to-chip bandwidth compared to the previous generation NVLink 5. Each GPU can communicate with neighboring GPUs at 3.6 terabytes per second, and the full rack achieves 260 terabytes per second of all-to-all fabric bandwidth. This means that when you are training massive AI models across dozens of GPUs, the communication bottleneck that has plagued previous generations is dramatically reduced. Training times that used to take weeks can now be completed in days. Morgan Stanley has warned that a massive AI breakthrough is coming in 2026, and the Vera Rubin is at the center of it. The investment bank's analysts predict that the combination of Vera Rubin's raw compute power and the growing ecosystem of AI software will trigger a wave of new capabilities that we can barely imagine today. With this kind of compute power, AI models that currently take months to train could be trained in days. Models with trillions of parameters, which are currently impractical to train on existing hardware, become feasible. And the cost per token for AI inference drops dramatically, making AI services cheaper and more accessible to billions of people around the world. The Vera Rubin also introduces a third-generation transformer engine, which is NVIDIA's custom hardware designed specifically for accelerating transformer-based neural networks. Transformers are the architecture behind virtually all modern AI, from ChatGPT to image generators to autonomous vehicles. By optimizing hardware for this specific architecture, NVIDIA is squeezing every last drop of performance out of the silicon, achieving up to 10 times the inference throughput compared to the previous generation for the same power consumption. Cloud providers including AWS, Google Cloud, and Microsoft Azure are already allocating Vera Rubin capacity for their customers. The projected on-demand pricing is $15 to $25 per hour, which is significantly more expensive than the H100 at $3.94 per hour or the B200 at $9.36 per hour. But for companies training massive AI models, the cost per token savings make the Vera Rubin worth the premium. A model that costs $100,000 to train on H100 hardware might cost a fraction of that on Vera Rubin, when you factor in the reduced training time. NVIDIA's competitor AMD is also working on next-generation chips with its Instinct MI400 series. However, NVIDIA maintains a commanding lead in AI-specific hardware, with an estimated 80 to 90% market share in AI training accelerators. The Vera Rubin platform is expected to ship to cloud providers in the second half of 2026, with broader availability including consumer and enterprise configurations expected in 2027. The Vera Rubin also introduces support for FP4 precision, which is a new numerical format that uses just 4 bits instead of the standard 16 or 32 bits. This allows for dramatically faster computation with minimal loss in accuracy for inference workloads. For training, the Rubin GPU supports FP8 and FP16 formats with full hardware acceleration. The introduction of FP4 support is particularly significant because it opens up AI inference to devices that previously could not run large models, including smartphones and edge devices. If you are using AI tools today, the Vera Rubin means better, faster, and cheaper AI services in the near future. Chatbots will be more responsive and capable of handling complex conversations. Image and video generation will be near instant, allowing for real-time creative workflows. And the next generation of AI assistants will feel genuinely intelligent rather than just fast at predicting text. For developers, the Vera Rubin opens up new possibilities for building AI applications that were previously impossible. Real-time language translation for entire conversations, personalized AI tutors that adapt to each student's learning style, and AI-powered medical diagnostics that can detect diseases earlier than any human doctor. These are not distant dreams, they are applications that could be built on Vera Rubin hardware within the next few years. For businesses, the Vera Rubin means competitive advantage. Companies that adopt AI early and leverage this new hardware will be able to automate tasks, analyze data, and make decisions faster than their competitors. The productivity gains could be enormous, potentially adding trillions of dollars to the global economy over the next decade. If you found this video helpful, smash that like button and subscribe for more tech news. Drop a comment telling me what you think about the Vera Rubin and what you are most excited about. And share this video with anyone who wants to know what is coming next in AI hardware. The future is being built right now, and the Vera Rubin is leading the way. NVIDIA official Vera Rubin platform documentation. Spherian Network NVIDIA Vera Rubin NVL72 Guide. Fortune, Morgan Stanley warns AI breakthrough coming in 2026. NVIDIA HGX platform specifications. Reddit r/hardware discussion on NVIDIA Rubin at GTC 2026. NVIDIA blog post on Vera Rubin architecture.